Hello everyone, welcome back to my YouTube channel. And today we are going to see State Board Class 10 Science 1 Chapter number 6 Refraction of Light. And this is the part 2 of this particular chapter. In a part 1, already we have studied about the refraction of a light through the glass slab. The diagram already we have studied, and then we have studied about the laws of refraction, then the refractive index we studied, and then how the path of the light ray is changing when it's traveling from the one medium to the another medium. What is the effect of the density of the material we have on the refraction of the light. Now today we are going to see the further part, the different phenomena of the nature which we call, like in that the first one what we will study today is the twinkling of stars. As already we have said about, when there is a change in the medium, there is a change in the path of the light. So when we talk about the twinkling of stars, what exactly is the concept behind it? See, when we talk about the atmosphere, then the atmospheric conditions affect the refraction of a light in certain extent, or in some extent we can call it. The air near to the hot road or the desert surface near the holy flames is hot and hence rarer than the air above it. Means, in a simple words, if I want to talk about, then if there is a flame, then the air which is near to this particular flame will have a high temperature, and due to that what will happen, the medium or the air which is near to that hot flame will have a lesser density. Okay, why? Because the temperature will be higher. The refractive index of the air keep increasing as we go to increasing heights. Means when we will go away from it, the temperature reduces, and temperature reduces means the density will increase. Once the density increases, the refractive index will increase. So this particular concept or this particular phenomena we are going to use to study about the twinkling of the stars. In twinkling of stars also, the similar kind of a thing happens. When we go away from the earth's surface, or when we go above the earth's surface, we can see over here what exactly we have. When we go away from it, the refractive index is what is changing. Increasing refractive index from the star till the earth we have, because here we have vacuum and the air is present over here, and due to that what happens, the refractive index changes, and due to that when the light starts traveling from the star and when it enters in the atmosphere, there is a change in a medium, and as it's going further near to the earth, what happens, the refractive index goes on changing or goes on increasing continuously, and due to that what happened, the path or the light ray which is traveling from the star to the earth is changing its path continuously, because as the refractive index will change for the different layer of air or the atmosphere above the earth's surface, the path will change, the light's path will change, and due to that what we feels, the appearance of the star is like shaking and the twinkling, because the refractive index changes the path of the light which is traveling continuously from the star to the earth. The next what we have to study is about the mirage. Mirage is also the similar concept which already we have discussed with the flame and all that part. Further is the effect of atmospheric refraction is the early sunrise and delayed sunset. Now here see what exactly is happening. The real position of the sun they have shown over here. real position of the sun is over here, and the observer is standing somewhere over here. So light ray, when it traveling in the vacuum and when it reaches up to the atmospheric layer, again it's changing its path and it's changing continuously. And due to that, what happens? The observer observes the sunrise. But in actual position, if we will talk about, the sun is below the horizon. Horizon is nothing but the one flat or the straight line of the person's or the observer's eye. That is called as the horizon. And due to that, what happened? We are getting the observations, or we observe as the sunrise, or just opposite of this at the sunset. We observe that sun is still there, but in a real timing or the real situation will be the sun will be already set in the west, or it will be below the horizon. So due to that, what happened? The actual sunrise and the sunset timing what we have is lesser as compared to the what we observe. So this is about the apparent position of the stars, sunrise and the sunset. The next what we have to study is the dispersion of light. The another important phenomena of the light, which we call as a dispersion of a light. Dispersion of a light is nothing but the process of a separation of a light into its component colors while passing through a medium is called the dispersion of light. Means, in a simple words, if I just want to make it a simple words, then the process of a separation of a light means the process in which the light, the white light, is splitting into its 7 component colors. That is called as the dispersion of light. And the Isaac Newton was the first person to use a glass prism to obtain sun's spectrum, which we call as the Webb-Cure. We call it as the Webb-Cure. You can see over here, this all the 7 letters what we have are nothing but representing the 7 different colors: the red, orange, yellow, green, blue, indigo and violet. So this is nothing but what the dispersion. When we talk about the dispersion, the white light which is originating from the sun goes under the prism and gets splitted into its 7 component colors. Now when we talk about the 7 component colors, why we are getting the 7th component? Because the white light, when we talk about, in that we have a radiations, the electromagnetic radiations of a different wavelength, and the different wavelengths are from between 400 to the 700 nanometers. In this particular different wavelengths, whatever the different wavelengths are having, they are producing a different sensation on the human eye, and due to that we are able to observe this different 7 colors. And this 7 colors, they have a different velocity under the different conditions or the different medium, and due to that they produces a different 7 colors at a different angles. You can see over here the 7 colors. Further, the next what we have to study is a partial and total internal reflection. When light enters a rarer medium from a denser medium, it gets partially reflected. That is, part of the light gets reflected and comes back into the, you can see over here what exactly is happening. This is an incident ray, and some part is getting refracted and some is getting reflected. Same way, if the angle will change, a little part will be here and little will be here, and there will be a one position when there will not be refracted ray, because reflected ray will also come over here, and the entire light is nothing but what remains into the liquid. So this kind of reflections are called as the total internal reflection, because no amount of a light is going outside. So all the light remains inside. So this kind of reflections are called as the total internal reflection. And the others what we have, we call them as the partial reflection. So this is about the total internal reflection and the refractive index. If you will see over here, the critical angle, that angle we call it as the critical angle. Which angle? The angle at which the refraction is at a 90 degree from the normal. If I will go back to the previous picture, you can see over here for one particular angle, the refracted ray is exactly at a 90 degree from the normal. So this particular angle will be called as the critical angle. This is about the critical angle and then the rainbow formation in the sky. Rainbow is a beautiful natural phenomena. It is a combined effect of a number of natural processes. It is combined effect of a dispersion, refraction and the total internal reflection. So first thing, what exactly is happening is the refraction over here. The light enters into inside and the refraction is taking place. Refraction, at the same time the dispersion of a light is also taking place, and then the total internal reflection and the rainbow comes out from here. Three phenomena, that is the dispersion, refraction and the total internal reflection, is nothing but the phenomenons which are responsible for the formation of rainbow in the sky. And this is nothing but the water droplet. Means, when we talk about the water droplets in the sky, when the rain occurs, then the small droplets of water is present into the sky or in the clouds, and when sun rays are falling on that particular droplets, they are going under the total internal reflection, and then the dispersion of a light takes place inside the droplets and the rainbow gets formed. So this is all about this particular chapter. In the next video, we are going to see about the exercise and the numerical of this particular chapter. But before going, you have some work, some activities which you have to complete and post back to me in the classroom. That is, you have to draw the further diagrams, that is a dispersion of light that you have to draw. Along with that, the total internal reflection, the partial and the total internal reflection, this diagram also you have to draw and post back to me in the classroom app. So this activity and the one activity which already I gave to you, that is a glass slab experiment. In that experiment's ray diagram you have to draw, that is given on a page number 74 of your textbook. The figure number 6.1, that is the refraction of a light passing through a glass slab, and these two activities you have to post back to me in the classroom. So this is all about this particular chapter. The next video, the next link we are going to have is the exercise and the numericals of this particular chapter in a coming video.